Jaeger! Welcome back to Phantom of Physics featuring Captain Levi from Attack on Titans on elevator problem. So here is example 2, and I noticed I forgot to change a few things, so quickly doing that. I looked online and a few things that would only match the description of this person with her actual mass is not Julia. Would be Eren Yeager, not Mikasa. I just found Mikasa actually has weighs a little bit more than Eren, probably because she's more ripped. As I was checking this online, 150 pounds and 68 kilograms. If you calculate it, it's about 68 kilograms, which is a little bit too much for what this reading here is. So again, in this problem, there's A, B, and C. I'm going to do A, B, and you will have a chance to try C. But this time, the question will be a little bit different. Eren stands on a scale and reads 598 newtons for his actual weight. Okay, so this is FG. He then enters an elevator and stands on the same scale during the entire elevator ride. We want to find the acceleration with direction of the elevator if Eren reads the following on the scale. Okay, so in these questions, we are trying to find acceleration, which is kind of the opposite of the last question. So let's start off with question A. Eren's going to step on the scale in the elevator, and this is his reading on the scale. So let's draw a free body diagram first. Okay, we have the force due to gravity acting on him, as well as the normal force. And it seems that this force over here is less than his weight here. And we know that the reading on the scale in the elevator gives us our normal force. So we're going to draw normal force a little bit less than his FG. From the previous video, we do know that when the normal force is less than your force due to gravity, your actual weight, you feel lighter, which means the elevator must be accelerating in the downwards direction. So we got the direction already. So knowing these things, let's write down our Fnet equation. To find out acceleration, we need to know the Fnet. That's equal to ma, and we don't know the mass of Eren per se, but let's see if we can find out Fnet. We can figure out Fnet from the balance of his forces, and we know that Fnet, I'm going to choose the downwards direction to be positive since the elevator is accelerating downwards. So we have Fnet is equal to the Fg minus the Fn. We know both Fg and Fn, so let's calculate Fnet first. So we have the Fnet is 41 newtons in the downwards direction, and we will then need to use it for Fnet equals to ma. But to find A, we need to know the mass of Eren. The mass of Eren isn't given in the question, so how should we find that? If you are thinking of finding it from Fg, his actual weight, you are correct. So let's do that here in this little corner where we know Fg is equal to the mass times gravity, in which we assume gravity is going to be down on Earth, 9.81. Isolating for mass, I'm just going to divide both sides here by g. We get 598 newtons divided by 9.81, giving us 69.958, which we will save this value. So don't forget we got to save all these sig figs because we can't round now. We don't round in the last step. 60.9 is a little bit less than Eren's actual weight. If you search it up online, I think his actual weight is 63 kilograms. Anyways, fan fact. Now we have his mass. Did I say his weight? His mass. We can now substitute into Fnet to solve for A. So let's rewrite that down here. Dividing for his acceleration, dividing both sides by mass, we get acceleration is Fnet divided by his mass. Fnet we know is 41, we just calculated that, divided by his mass, which is 60.9 ... We get 0.672. which we're gonna round to 3 significant figures. So that's 673 meters per second squared down in the downwards direction. Don't forget the direction when you're stating a vector, which is acceleration. Okay. Okay, I do the next one. Now this time, Aaron reads 0 on the scale. Ooh, that's an interesting case. So let's analyze this a little bit more carefully. So since 0, this is talking about his normal force. So he has no normal force right now. He is not reading anything on his scale. What do you think is happening here? And which means the floor, the bathroom scale, is not pushing up against him at all. And that's telling us something. It's telling us he has a net force in a downwards direction because there's no other forces acting on him except Fg. That means acceleration must also be downwards. And I'm going to label that as our positive direction for now. You might already know what's happening or you have an idea, but let me just go through all the steps. So hopefully it all makes sense in the end. We have F net equals to MA, in which his F net will only be Fg because that's the only force acting on him, and it'll be and I'll label it as positive in the downwards direction. So we just have Fg, and that's equal to his mass times his acceleration. We know Fg is equal to mg, so let me substitute this all in here. Okay, so I have mg equals to ma. His mass is still his mass. That's not going to change. We can just cancel these two out. We are left with his acceleration in the elevator is going to be equal to that of gravity. Uh-oh. What does that mean? If he's accelerating downwards at a rate of gravity, that means he must be falling. He must be in free fall. So the elevator cord snapped or everything just failed. Oh my goodness, poor Aaron. He's gonna survive. He's probably got his 3D gear and everything. He can shoot himself out of the elevator. Or maybe not, I don't know, we'll see. But that's an interesting case here, where we have a 0 newtons reading on your scale. That's going to mean this person is in free fall. Let's finish up our question here because we haven't written anything down. This is 9.81 meters per second squared in the downwards direction. If you're ever worried your elevator is going to stop and sometime maybe fall down, or it will break, the cords will break, that's not going to happen. Your elevator's got a lot of security measures, and if you're wondering what they are, you can check out another video. I might be able to link down below. Okay, so right, that's our 2 problems. This is now your turn to try question C on your own. Good time to pause the video. And here I go on fast play. Okay, so we have 6 to 9 newtons, that's our Fn. Drawing a free body diagram, you have Fg acting on Aaron, and here Fn is greater than Fg. You're going to draw a longer arrow. Acceleration must be in the upwards direction, which I will determine as my positive direction. We have F net equals to ma, and the sum of the forces is Fn minus Fg in the opposite direction. I'm going to put these 2 equations together, actually, rewriting it and solving for acceleration by dividing both sides by mass. And now we can substitute all our values into this equation since we have Fg and the mass of Aaron. And dividing everything out on our calculator, we get something like a 0.5085, which we're going to round to 3/6 figs, so 0.5089 meters per second in the upwards direction. All right, and there was that. So in this solution, this solution here, I did a little bit differently, where I merged 2 steps together. I combined these 2 F-net equations, essentially equating the sum of the forces with m times a, mass times acceleration, and then I just solved for a as in once and substituted everything in one step. you might have done it differently. You might have first calculated Fnet from Fn minus Fg, giving an Fnet, and then Fnet equals the ma. You divide up both sides by the mass to get acceleration, which is also fine. And if you don't remember how to do that, refer to question A, where I went through those steps with just different values for acceleration, and also using upwards as the positive direction since Fn is greater than Fg. Okay, so hopefully this video taught you a few things and that you feel a little bit more comfortable tackling your elevator problems. Thank you for watching Elevator Problems featuring, well, in this case, Eren Yeager on Attack on Titan. Fat Mama Physics signing out.